Okay, these are two examples from 2.1 about, this one's about midpoint and this one is about the distance formula. So for number 13, they give us the midpoint between point 1 and point 2, and then they give us point 1 and they ask us to find point 2. So what I would want to do is I would want to use the midpoint formula, but instead of putting in my x1 and x2 and dividing it by 2, I'm going to put in my x1, I'm going to put in my x of my midpoint, and I'm going to find point 2. So the equation is the midpoints, sorry, the x value of the midpoint, x value of P1, x value of P2. The x value of the midpoint is equal to the x value of point 1 added to the x value of point 2 divided by 2. What is my x1 and x2? x1 is -8, and I don't know my x2. That's what I'm trying to find out. But my midpoint, oh, sorry, x of my midpoint is -5. So instead of saying it's -8 plus another number divided by 2, I'm going to say -5 is equal to, so I'm replacing that x value with -5. I'm going to replace this x value with -8 plus, and I'm just going to call this regular x because that 2 is unnecessary. There are not more than one x's. There's not more than one x value anymore, so I don't need to use the subscript. So now I just have the equation -5 is equal to -8 plus x divided by 2. X is being added to -8, and then x is being divided by 2. However, this is a grouping symbol, so I'm going to multiply by 2 or get rid of the denominator of my fraction before I add the 8. So I'm just going to multiply this side by 2. Anything I do to this side of my equal sign, I'm going to do to this side. It's inside the parentheses, outside. All right, 2 times -5 is a -10. That was to cancel that. So I just have -8 plus x, or x minus 8. Still want to isolate x, so I'm going to add 8, add 8. X is -2. So I found that the x value of point 2, or my second point, is -2. Now I need to find my y value, right? So just like we did, the x of my midpoint is equal to x1 plus x sub 2 divided by 2. I'm going to say the y value of my midpoint is equal to the y value of my first point added to the y value of my second point and then divided by 2. So you can kind of see how the grouping symbols created, right? I add them, then I divide by 2. So we know that the y value of my midpoint is the number 2, and the y value of my first point is 9. So I'm going to say 2 is equal to 9 plus y divided by 2. Again, I dropped the subscript because I don't have m and 1. I just have a y that I'm solving for. Exact same order. Since it's being divided by 2, I'm going to multiply by 2. Anything I do to this side, I have to do to the other side. 2 times 2 is 4. 4 is equal to 9 plus y. Subtract 9. Subtract 9. 4 minus 9 is -5. So, second point is -2, -5. If you put each of these into Desmos, this one should be between these two. So to get from -2 to -5, 2, 3, 4, 5, I subtract 3, right? -2 minus 3 is -5. If I minus 3 again, I get to -8. So that's good, right? There's a pattern. -5 to 2, I add 7, right? I get 2, add 7 again, I get 9. So that checks out even without graphing it. Number 14 says I have a triangle. I know this is terrible. The triangle should look like this. if we're actually graphing it, because that would be 2, 2, 2, negative 1x. Yeah, 2, 2, 2, negative 1. It would be like that. Anyway, sorry. Anyway, just saying these are poorly labeled. It wants to know, is this an isosceles triangle? An isosceles triangle has two sides of equal length. A right triangle has one side that is perpendicular to one of the other sides, but it also has this leg squared plus this leg squared is equal to the hypotenuse, or the longest side, squared. So that would be a right triangle. If it's a right triangle, then whatever this distance is added to this distance squared will equal this distance squared. And if it's an isosceles triangle, that means that two of the sides are the same length. So the length of leg 1 is equal to the length of leg 2. Basically, it's just asking us to find each of the sides and see if we notice anything about it. So the way that MyMathLab does it is they ask for the length side of P1, P2. Length side P1, P2. And all they're asking is, what they mean by that is, what is this? What is the length of this? Okay, so we're going to use the distance formula. The distance formula says it's going to be the square root of x minus x squared plus y minus y squared. In our case, this will be my x2, y2. Oh, sorry, you can't see it. This will be x1, y1. Zoom out a little further. All right. So x2 is -1. x1 is 2. So -1 minus 2 squared. -1 minus -1 squared. So that was a -1. That was a +2, but there's a minus between them. That was a -1, and that was a -1, but there's still a minus between them. So just make sure you got all your signs correct. -1 minus 2 is a -3 squared, with in parentheses is the same as 3 squared. -1 plus 1 is just 0 squared. So I have the square root of 9, because -3 squared is 9. So that distance is 3. Okay. Then it's going to ask you for length side, I don't know, I haven't. P2, P3. Same thing. X minus x squared plus y minus y squared. Or you could say y3, x3, y3, x2, y2. Anyway, I'll call x3 my x2 and x2 my x1. So 2 minus -1 squared 2 minus -1 squared. And that does make sense because this was 2, 2, and this is -1, -1. So they're going to look a little bit the same. When I simplify, 2 minus -1 is just 2 plus 1. So that's 3 squared plus 3 squared, which is the square root of 9 plus 9, which is the square root of 18. And then when we factor out 18, 18 becomes 9 times 2. The square root of 9 is 3, so the final, I know it kind of seems like you can take out both of those 9s and make them each a 3. However, they're being added, they're not being multiplied. So 9 plus 9 is 18, and then when we factor 18, 18 isn't 9 times 9, 18 is just 9 times 2, then 9 becomes a 3. So it's 3 squared of 2 as our simplest simplified form. And then our last one is going to be, what is the distance of length side P1, P3? What is this one? Yeah, it'll still be the distance is the square root of x minus x squared plus y minus y squared. So I'll say this one's x2. So I'll say it's 2 minus 2 squared plus 2 minus -1 squared. 2 minus 2 squared is 0 squared. 2 minus -1 is 3 squared. So again, that's the square root of 9, which is 3. So this one's 3. So it is an isosceles triangle because an isosceles triangle has two sides that are the same. It is isosceles. Can something be isosceles and right triangle? I don't even remember because it's been so long since I've done geometry. So if it's an isosceles triangle, leg 1 will match leg 2. The two of the legs match, so it is isosceles. If it's a right triangle, then leg squared plus leg squared will equal the longest leg squared. So these two are clearly shorter because 3 is smaller than 3 times the square root of 2. So if I take this leg, square it, this leg, square it, will it equal that number squared? Good? Like you could say this is leg A, leg B, and leg C. Is A squared plus B squared equals C squared? Is what we're asking about right triangles. So A was 3, B is 3, C is 3 squared root of 2. 3 squared plus 3 squared equals 3 square root of 2 squared. 3 squared is 9. 3 squared is 9. 3 squared root of 2 squared. 3 square root of 2 squared is 18. Oh, that's nice. Or 3 square root of 2 times 3 square root of 2 is 3 times 3 is 9. 2 times 2 is 4. So we had 9 outside the radical, 4 under the radical, but the square root of 4 is 2, so it's 9 times 2, which is 18. So yes, it is both a right triangle and an isosceles triangle.